Good morning, freshmen. This is day 2 on exponents. The first day we dealt with the zero rule, that anything to the 0 power is equal to 1. Then we also did the reciprocal rule. If you have a negative power, it flips it into the denominator if you start in the numerator, and then the power becomes positive. And if I start in the denominator and I go back to the numerator, it becomes positive. So those were the two that we've done before. We also had a lesson on scientific notation, and I'll show you how to use that with this particular lesson. Today we're going to deal with the product rule. This is where I have x to a power times x to a different power, and you add the two powers together. The easiest way to show this is if I had x cubed times x squared. X cubed means x times x times x. X squared is x times x. But when I get done, how many total do we have? Well, we have 5. So we just add the powers. Alright, so let's look at some examples. When you have real numbers, coefficients with these, you handle them like normal multiplication. So if I gave you 3x to the 4th times 4x to the 5th, you multiply the 3 and the 4 just like always, and you would get 12. And then you would deal with the x's. And since the bases are the same, notice they're both are x, I add those two, and my final answer is x to the 9th. So when you use the product rule, numbers are handled, the coefficients are handled like normal. The powers, the bases are the same, you just add them. I can have different kind of bases. So if I had x squared y to the 3rd, times x to the 5th, y to the 8th. The product rule says you deal with the ones that are the same. So here's my x base, so I would add the powers and I'd get x to the 7th. Then I would do my y's, these, and then you just multiply. You show the multiplication, you add, according to the product rule, and I get 11. So this would be my final answer. Again, you take the x's, you add those powers, the y's, you add those powers. You can also have different bases. I've used x and y, and that's usually, but I could have a number as a base. So I could have 10 to the 3rd times 10 to the 4th. To solve this, the bases are the same, and that's the one rule you have to have. Then you add the powers. So, the base is the same, add the powers, and there's my final answer. I do not want it expanded where you'd have 1 followed by 7 zeros. This is the type of answer I want. Now, along with that, with our scientific notation, if I gave you 2.5 times 10 to the 8th times 6 times 10 to the 3rd, you have two problems here. You first multiply the 2.5 times the 6, well that's 15. Then the 10s, same base, add the exponent, so I have 10 to the 11th. Now the only problem with this is not written in scientific notation. We need to move the decimal one place to the left. And when I move it one place to the left, I add another power. So this becomes 1.5 times 10 to the 12th. Alright, let's do about 2 more examples, then we'll review everything again, and there's your lesson. All right, if we take the top one, when we deal with the coefficients, that's these three guys here, that is normal multiplication. 2 times 7 is 14 times another 2 is 28. Then you look, and we try to always list our variables alphabetically as you can. So next I'm going to look at the x's. There is only one term with x's, so I'm just going to have an x squared. Then I'm going to look at the y's. Here I have y to the third, y to the fourth. Bases are the same, they're y. I add the exponents, and my final answer will become 28x squared y to the 7th. Now, this last problem combines all three of the rules that we've had at this time. Now, what can you tell me happens when we have something to the 0 power? Well, we know that is 1. If you look at the 7 times 1, that's my only coefficient, so I know I'm going to have a 7. Now, here's one of those things you assume, and we really don't talk about. What is the power on that m? None is written. We assume it is 1. Anytime you have a variable, no power written, you assume it is 1. And then, since we're going to do alphabetically, here I have m squared, m to the first, so I'm going to add those powers, I'm going to get n to the third. Now, at this point, I have only the one n to the negative second. You know that you cannot have a negative exponent in your final answer. So I need to use the reciprocal rule. The 7 and the m to the third stay in the numerator, and the n squared goes in the denominator. All right, let's go back to the rules. Here is our new rule. If the bases are the same, we add the powers. Our other two rules. We took an example. We took the coefficients, we multiplied those regular. The bases were the same, we added the exponents, and there's our final answer. Here, with these two terms, we deal alphabetically first. We look at the x's, we add those powers only. Only the x's can be added together. Then we add the y's only together. Then we talked about different bases. I am not expecting you to expand these, so you don't need your calculator for these. 10 to the third times 10 to the fourth, base is 10. You add the power and you get 7. If they say expand, you'd write 1 and 7 zeros. We also can use this with scientific notation. If I give you these two numbers in scientific notation, you multiply these numbers regular, the tens, you add the powers. Then you rewrite it in scientific notation. That's the homework. If you have any question, talk to the senior calculus kids. They can help you. You're done.